Okay, for question number 33, we have to find the area of the region bounded by the curve. So this is the curve, and let's see what type of curve this is. And let me divide this with 36. So divide all the terms with 36. Okay, this is now 9. So finally, we have the equation of the curve x squared by 9 plus y squared by 6 is equal to 1. And I can write it as x squared by 3 squared plus y squared. This is 9, this is 36. So I can write it as 6 squared is equal to 1. So this is the equation of the ellipse, which is of the form x by x squared by a square. So this is x squared by a squared plus y squared by b squared is equal to 1. And if we compare this equation with the standard equation of the ellipse, here b square is greater than a square. So that means the ellipse has its major axis on y-axis. So let me show you how. Okay. So here b is 6. If we compare these equations, so b is equal to 6 with is the semi-minor axis, and because its b is greater than a, so that means that our ellipse is on, it has a major axis on the y-axis. So this is how the ellipse is, and this is actually 0, and this should be 6, the distance. So if I mark them 1, 2, 3, 4, 5, and 6, and a is 3, so this should be 3. 1, 2, and 3. And now we have to find the area of the region bounded by the curve using integration. So that means we have to find this is the all the area bounded by the curve. So let's find out the area in the first quadrant, and we will multiply that with 2. So the required area here is equal to 4 times, because this ellipse is symmetrical about the x and the y axis. So we have four regions, 1, 2, 3, and 4, and all these are symmetrical. So I will find the area of this region and will multiply it with 4. So let's find out the area of this region under the curve, and we'll multiply it with 4. So 4 into area of the integration will go from 0 to 3 y into dx. Let's find out the value of y. So this is 0 to 3y, and we can get the value of y from the equation this. So y square is equal to 36 minus 4x square, which gives me y. I can take 4 common here, so this is 9 minus x square, and which gives me y square is equal to 4. So this is 3 square minus x square. Okay, if I take 4 common here, this is 4 into now into 3 square minus x square, and y is equal to under root of this. So y should be now under root of this. So under root of 4's root is 2. So 2 into 3 square minus x square is the value of y. So now we have already taken 4 out here. Okay. So y square is equal to 4 into the value of y is 2. This is 2 under root of 3 square minus x square into dx, which gives me 4 2s are is 8. So we are left with 0 to 3. This is 3. And integration of this is now of the form a square minus x square into dx. Okay. Now we know that the integration of the formula for integration of a square minus x square into dx is this is equal to the formula is x by 2 under root a square minus x square plus a square by 2 into sine inverse x by a. So let's use this formula here. So which gives me a into this is x by 2 and under root of a square minus x square will be 9 minus x square plus a square by 2 which is 9 by 2 sine inverse x by a which is 3, and it has to be evaluated for the limits 0 to 3. Okay, so let's evaluate for it for the limits. So 8 into, let's put in the value first 3. So this is 3 by 2 and 3 square is 9. So this is 0 plus this is 9 by 2 sine inverse x is 3 by 3 and minus. So if we put 0 here, so this term is 0 and this is uh, 9 by 2 sine inverse 0 by 3 0 sine inverse 0 is 0, so this whole term is 0. Now finally we are left with 8 into this is 9 by 2 and this is 1. This is sine inverse 1. 8 into 9 by 2 into sine inverse 1. So the angle for which value of sine is 1 is 90, which is pi by 2. So this is 4, 2, and which gives me 18 pi. So this is 18 pi square units is the area of the required region.